This is a video about selection and Hardy-Weinberg equilibrium. For this video, we will use penguins. Penguins are a diploid organism that reproduce through mating. In penguins, one autosomal gene controls the color of the penguin. This gene has two alleles, big G and small g, and there are 3 genotypes and 3 phenotypes, gray, purple, and blue. We have an initial population of 150 colorful penguins. There are 54 gray, 45 purple, and 52 blue. In order to see if this population is consistent with Hardy-Weinberg equilibrium, we must calculate the frequency of each genotype and each allele. To help us do this, we will use the Hardy-Weinberg law equations. P represents the frequency of the big G allele, and Q represents the small g allele. Now to calculate the frequencies. The frequency of big G allele, P, is the number of big G alleles over the total number of alleles. The frequency of small g is calculated the same way. Remember that both of these must add up to 1. Then we can use P and Q to calculate each genotype frequency. Again, remember that these also have to add up to 1. Now we can use the genotypic frequencies in a chi-square test. A chi-square test is a statistical test that shows if a data set fits or violates a null hypothesis. Our null hypothesis is that this population has Hardy-Weinberg proportions for the color locus. We compare the observed amount of each genotype to the expected amount, which is calculated with the genotype frequency. We then get our chi-square value, shown in the bottom right of the table. Now we have our chi-square value. We can compare it to our critical value given by the degrees of freedom. Degrees of freedom are calculated by taking the number of genotypes divided by the number of alleles, giving us 1. The critical value for this 1 degree of freedom is 3.84. which is much greater than our chi-square value of 0.0097. This means we fail to reject our null hypothesis, and this population fits Hardy-Weinberg proportions. Selection is based on fitness of an individual. Fitness is the ability to survive and reproduce. If a genotype is more fit, the genotype and allele frequencies will change over time, breaking Hardy-Weinberg equilibrium. Fitness is shown mathematically as W, where higher values are more fit. In penguins, gray have a fitness of 1, purple 0.75, and blue 0.25. Now we can use fitness to see how frequencies will change due to selection. This is calculated by multiplying the initial frequency by the fitness. These values are called unadjusted survivors because they do not add up to 1. To find the actual frequency, we divide by the average fitness, which is the sum of the unadjusted survivors. This is an example of directional selection. This means the big G allele is favored over the small g allele. This means that gray and purple penguins are favored over blue. The reason for this is that the darker color penguins allow them to absorb more wavelengths of light, giving them more heat in the cold Arctic. Purple skin is not as good as gray skin at catching heat, but it is enough to survive longer to reproduce. Over time, the frequency of gray and purple penguins will increase, and blue will decrease. That's the end of the video, and here are my references.